And I spent so much time focusing on lakes that I totally forgot that part two also should include flowing fresh water, those lotic systems. So bear with me while this one is very short, at just I think 3 slides long for part two, a continuation after my 15-minute time limit was up. Okay, so again, um, when we have flowing water, we call that a lotic system, flow low. And what that does is it moves our water from mountains to the oceans, or from wherever that water does fall down, but that would be the origin. And an area that drains into the same basin is going to be called a watershed. So if we think about the topography of the earth, and we'll see a picture of this in a minute, but if you think about that topography, then you can see where high areas will feed their water down into low areas. And you can think about this just within your own neighborhood. Where does the water tend to go? And I know that we've talked about in our class that the water that is right around here feeds into Sweetwater Creek, the creek that runs right through Ronald Reagan Park, and that feeds into the Yellow River, which is going by and through some of our neighborhoods, going down through the Five Forks, pretty much running alongside of Five Forks until you get around Lake Lucerne, and then it passes by the Yellow River Game Ranch. And then that feeds into the Ocmulgee watershed basin, and then that eventually will flow into the Atlantic. So the idea of a watershed is, again, any water that's going to flow into one water source. And the Mississippi is the largest of all of our watersheds, taking about 2/3 of the country's drainage water with it. This is going to take also into account surface water. Lakes are part of our watershed, and runoff water becomes part of the watershed as well. So again, we don't have to start in the mountains. That's where we start drawing the watershed's boundaries, because that's the topmost part. And so as water flows down, we want to start at the topmost elevations. There are 3 aquatic life zones in a river or stream, any of those lotic systems. And this, again, has to do with a difference in the nutrient availability and temperature and some of those other limiting factors. So our first zone is the source zone. That's going to be up at higher elevations. We tend to have more briskly running water. The water tends to be colder on account of the elevation. And the stream has high oxygen content, and that's mostly because of the rapid water movement, but it's also because of the cold. Both things will increase the oxygen in the water and the capacity of the water to hold the oxygen. The transition zone would be more like what we are here in the Atlanta area. Transition zone, it flattens out quite a bit, but you still have a decent flow to the river. And then in the floodplain zone, you have almost completely flattened out. The flow is very slow by comparison, especially to that source zone. And with slow moving water also comes depleted oxygen and increased temperatures. So we're going to look at a picture that will show you all of these concepts thrown together. So this is a watershed, and you can tell it is a watershed because the upper or the outside areas have the highest elevation. So there's no water going to escape from this marked area. And then they've divided it up into 3 different categories. Your source zone is at the top. You've got rain and snow, you've got glacier melt, you've got upper mountain lakes. And so again, everything up there, because of that elevation, you've got lots and lots of speed. You also have very cold water. And anytime you've got speed, you get bubbles. Anytime we see bubbles, white water, for example, the term for rafting, anytime you see white water, that's water with oxygen in it. So you have high oxygen levels, low temperatures, and high speeds. And then if we go all the way down to the floodplain zone, you can see that other streams have joined in. You've got tributaries coming in. But as we go to the floodplain, we've got the opposite factors. We have higher temperatures. We have less oxygen. We have slower speed. One of the other things that will happen is with turbidity. Again, turbidity is that word that means how cloudy is the water. Down in the floodplain, we have high turbidity because we've had a lot of sediment fed into our system. Up in the source zone, we have low turbidity, or we have very clear running water. And that's because, again, if you look at that picture, we don't have a lot of soil. We've got mountainy areas, so lots of rocks. You're not going to pick up sediment and nutrients. So the other thing to keep in mind is that while there are some organisms that prefer source zone, namely a mountain trout, a stream trout, rainbow trout, they will like to be in the cold oxygenated water. But the majority of our fish like to be in slow moving, well nourished water, even if that means that it's hard to see them. But you have a lot of people who do fishing in rivers or in lakes, and we've got that same idea of a lake with a lot of nutrients because it's slow moving, and that's where the streams are going to dump for just a little while at least. So again, here that is broken down for you guys to write down 3 aquatic zones: source, shallow, cold, clear, and swift. Very high DO. DO stands for dissolved oxygen, that oxygen that's in the water that fish can use. Low nutrients, so not many producers. Transition, it's gotten wider, deeper, warmer, and slower. It's more turbid. That, again, that word turbidity means cloudiness. Sediment is how we get it. Lower dissolved oxygen. So you're at a midpoint here, and then the floodplain is the exact opposite of the source zone. You're wide, deep, warm, and slow, very low dissolved oxygen, and a lot of silt and sediment. Again, that part's going to be good for a lot of your organisms. The low dissolved oxygen, though, could be problematic. Get lots of catfish down in the floodplain zone. So when you're thinking about the those shows where they go noodling, that's what we're talking about here, is the floodplain zone.